Photovoltaics is the name of a method of converting solar energy into direct current electricity using semiconducting materials that exhibit the photovoltaic effect, a phenomenon commonly studied in physics, photochemistry and electrochemistry. A photovoltaic system employs solar panels composed of a number of solar cells to supply usable solar power. The process is both physical and chemical in nature, as the first step involves the photoelectric effect, from which a second electrochemical process takes place involving crystallized atoms being ionized in a series, generating an electric current. Power generation from solar PV has long been seen as a clean, sustainable energy technology which draws upon the planet's most plentiful and widely distributed renewable energy source, the sun. The direct conversion of sunlight to electricity occurs without any moving parts or environmental emissions during operation. It is well proven, as photovoltaic systems have now been used for 50 years in specialized applications, and grid-connected PV systems have been in use for over 20 years. They were first mass-produced in the year 2000, when German environmentalists including Eurosolar succeeded in obtaining government support for the 100,000 roofs program. Driven by advances in technology and increases in manufacturing scale and sophistication, the cost of photovoltaics has declined steadily since the first solar cells were manufactured, and the levelized cost of electricity from PV is competitive with conventional electricity sources in an expanding list of geographic regions. Net metering and financial incentives, such as preferential feed-in tariffs for solar-generated electricity, have supported solar PV installations in many countries. With current technology, photovoltaics recoups the energy needed to manufacture them in 1.5 to 2.5 years in southern and northern Europe, respectively. Solar PV is now, after hydro and wind power, the third most important renewable energy source in terms of globally installed capacity. More than 100 countries use solar PV. Installations may be ground-mounted or built into the roof or walls of a building. In 2014, worldwide installed PV capacity increased to at least 177 gigawatts, sufficient to supply 1% of global electricity demands. Due to the exponential growth of photovoltaics, installations are rapidly approaching the 200 gigawatts mark, about 40 times the installed capacity of 2006. China, followed by Japan and the United States, is the fastest growing market, while Germany remains the world's largest producer, with solar contributing about 7% to its annual domestic electricity consumption. Etymology: the term photovoltaic comes from the Greek phi sigma, meaning light, and from volt, the unit of electromotive force, the volt, which in turn comes from the last name of the Italian physicist Alessandro Volta, inventor of the battery. The term photovoltaic has been in use in English since 1849. Solar cells. Photovoltaics are best known as a method for generating electric power by using solar cells to convert energy from the sun into a flow of electrons. The photovoltaic effect refers to photons of light exciting electrons into a higher state of energy, allowing them to act as charge carriers for an electric current. The photovoltaic effect was first observed by Alexander Edmund Becquerel in 1839. The term photovoltaic denotes the unbiased operating mode of a photodiode in which current through the device is entirely due to the transduced light energy. Virtually all photovoltaic devices are some type of photodiode. Solar cells produce direct current electricity from sunlight, which can be used to power equipment or to recharge a battery. The first practical application of photovoltaics was to power orbiting satellites and other spacecraft. But today the majority of photovoltaic modules are used for grid-connected power generation. In this case, an inverter is required to convert the DC to AC. There is a smaller market for off-grid power for remote dwellings, boats, recreational vehicles, electric cars, roadside emergency telephones, remote sensing, and cathodic protection of pipelines. Photovoltaic power generation employs solar panels composed of a number of solar cells containing a photovoltaic material. Materials presently used for photovoltaics include monocrystalline silicon, polycrystalline silicon, amorphous silicon, cadmium telluride, and copper-indium gallium selenide sulfide. Copper solar cables connect modules, arrays, and subfields. Because of the growing demand for renewable energy sources, the manufacturing of solar cells and photovoltaic arrays has advanced considerably in recent years. Solar photovoltaics power generation has long been seen as a clean energy technology which draws upon the planet's most plentiful and widely distributed renewable energy source, the sun. The technology is inherently elegant, in that the direct conversion of sunlight to electricity occurs without any moving parts or environmental emissions during operation. It is well proven, as photovoltaic systems have now been used for 50 years in specialized applications, and grid-connected systems have been in use for over 20 years. Cells require protection from the environment and are usually packaged tightly behind a glass sheet. When more power is required than a single cell can deliver, cells are electrically connected together to form photovoltaic modules, or solar panels. A single module is enough to power an emergency telephone, but for a house or a power plant the modules must be arranged in multiples as arrays. Photovoltaic power capacity is measured as maximum power output under standardized test conditions in WP. The actual power output at a particular point in time may be less than or greater than this standardized, or rated, value, depending on geographical location, time of day, weather conditions, and other factors. Solar photovoltaic array capacity factors are typically under 25%, which is lower than many other industrial sources of electricity.